I would like to demonstrate how the PS-525 and PS-525A compare to a precision calibration pressure tester. Here we have a Mensur 8201 that was designed for calibrating air data testers. I will show you various altitude and vertical speed comparisons, and then I will show you the airspeed comparisons. At the moment, we'll start at 0 feet, and we'll go up at 3,000 feet per minute. I'll punch in 1,000 feet, and you can see how the vertical speeds are. This is right at 3,000, and this is right around 3,000, and they track each other quite well. I'll go to some other vertical speeds as well as we go along in the test. And there we go, 1,000 feet. I'll put in 5,000 feet, and I'll put in 5,000 feet vertical speed, and go. And here again you see the correlation between the two testers. Quite accurate. And then I'll go on up to 6,000 feet per minute. And let's go up to 10,000 feet. You can see the altitude also keeps up quite well with the pressure controller. Very good. Now I'll put it to 10,000 feet per minute, and let's go to 15,000 feet. I know normally test an aircraft you would not exceed 6,000 feet, but I'm just demonstrating the capabilities of this system. And you can also see the accuracy of the altimeter as well. They correspond very well. Now we'll go up at 20,000 feet per minute to 20,000 feet. Again, at 20,000 feet, they're right on in accuracy with the altimeter. And I'll put it at maximum vertical climb here, 40,000 feet per minute, just to save on time, and we'll go up to 30,000 feet, then 40,000. Oops. There we go. 30,000 feet. of altitude, then we'll go to 40,000 and then 50,000, and then go back down again. There we go, 30,000 feet. Now 40,000. They're right about 40,000 feet. Now 50,000. The PS-525 stops at 35,000 feet, but the PS-525A, which has 2 vacuum pumps in it, can go up to 50,000 feet. So this will give you an indication of what it's like, the accuracy comparison at 50,000 feet. So here you see at 50,000 feet, it's 5 to 10 feet off. No big deal at all. Alright, now let's go back down to 10,000 feet, and then I will descend back to 0 with a smaller vertical speed, just to show you smaller vertical speed rates, because I did start at 3,000 feet. So I'll try to show you maybe 1,000 feet per minute or so. Alright, there we go at 10,000 feet. And for this illustration, I'll put the Mensur tester just in the measure mode, so it's not controlling anything. That way I can control it manually with the needle valve on the PS-525 tester. Measure, and if I do a small leak with the needle valve venting the system, there's about 250 feet per minute. Well, let's see, went back down to 120, but here you have quite good accuracy between the two testers. Now keep in mind, vertical speed indication is what you're doing. You're tracking a moving target. It's pretty hard to get that exactly right, especially at the lower speeds where there's such a small change in air pressure. Okay, here 170 or so. We'll go up a little faster. That's 720. Go closer to 1,000. It's 1,250 or so. And go up to about 2,000. good, and then I can just turn it off, back to 0 or nearly 0. Then I'll just open up the vent to bring it back down to ambient air pressure. I can descend very rapidly with this one. It's a solid state sensor. You would not want to do that on a mechanical, when connected to an aircraft with a mechanical altimeter, but in this case on the bench it's no problem. Okay, and oops, I wanted to go back down to 0, and it had some vacuum still in the system when I activated the controller. Okay, well, there you go, back down to 0 feet at sea level. So there you see, that's a comparison with a high precision calibration tester, and this is the PS-525 tester doing very well, keeping up with a very high precision tester.